Okay, Etam, welcome to your video tutorial looking at using SOHCAHTOA still, the trigonomic ratios, to solve, but this time we're going to have to look at solving for the denominator. So far we've had our unknown always on the numerator. This time we're going to flip it around and have our unknown on the denominator and see how that changes. So far we've been dealing with equations when we're finding missing sides on a right-angled triangle with trigonometry, with having the pronumeral that we don't know in the numerator. However, sometimes the unknown is in the denominator and these problems can be solved pretty easily. It just takes an extra step. Okay, so first thing we do with any trigonomic ratio, it says find the unknown value. Okay, I've been given two sides and an angle. Okay, so I have to use trigonometry. I can't use Pythagoras. So I write SOHCAHTOA at the top of my page. That was a weird O. Okay, and I label my triangle. Here's my angle. There's my adjacent. There's my hypotenuse. There's my opposite. The ones that I have are the opposite and the hypotenuse. Okay, opposite and hypotenuse means it's going to be sine. Okay, so the sine of 35, or sine theta, here's my formula, sine theta equals opposite over hypotenuse, okay? And then when I sub in the sine of 35, the opposite is 2, and the hypotenuse is x. See, this is what I'm talking about. Remember how last time we would have had it as x over 2, and then we just times that by 2 and we get the answer? This time I have my pronumeral on the bottom, okay? Watch what I do. I don't really have much of a choice. It's 2 divided by x. I have to get rid of the division first. I don't actually have a choice. So I move the x over to this side. I get rid of it on that side. It's a divided by x, sorry. How do I get rid of a divided by x? Times it by x. If I times this side by x, okay, that'll cancel out and I'll just be left with a 2. But I have to times the other side by x. So sine of 35 times x equals 2. Now I'm hoping what some of you can see is how I can get this x by itself now. Okay, the x is being times by sine 35 at the moment. Okay, so the x is being times by sine 35. So if I want to get that x by itself, I take away the sine 35. To take away the sine 35, if it's being multiplied, I divide it. If I divide this side by sine 35, okay, and cancel out that and that and that and that, all I'm left with is x. If I do it to that side, I have to do the same thing to the other. So sine of 35, and now the 2 was over there originally, so, oops, sorry, I've done that wrong. Okay, the 2 was over there originally, okay, so when I divide this side by sine 35, it's going to have the 2 on the top, divided by sine 35. And to 2 decimal places, because I always do it, is x equals 3.49. That means that this side here is 3.49. Does that seem about right? Well, it's a hypotenuse and it's longer than the opposite, so I think I got the hang of it. Let's have a look at this one here. SOHCAHTOA. Okay, here's my angle, this is my adjacent, that's my hypotenuse, which means I'm going to be using cos theta equals adjacent over hypotenuse. Cos of what was my angle? 40 equals my adjacent is 3. My hypotenuse is x. I know now that I have to deal with the division first, so I'm going to get rid of the x. I'm going to times this side by x, and they're going to cancel out, so I'm going to be left with 3. If I times that side by x, I have to times this side by x, so the cos of 40 times x equals 3. Okay, x by itself, I get rid of cos 40 on this side. If it's being times by x, I divide it, and that'll cancel that out. If I do it to that side, I have to do the same to this side, cos 40. Okay, and that one, guys, to 2 decimal places, 3 divided by cos 40, 3.916. So that becomes x equals 3.92. Because remember, that's 6, if you put it into calculator, 3.9162. Yeah, you have to make sure that you round that one up because that 6 is above 5. Okay, last example, SOHCAHTOA. You can probably guess which one I'm going to do here. that is my adjacent, that is my opposite, that is my hypotenuse, which means that I'm going to use tan. The tan of theta is my opposite over my adjacent, so it's the tan of 48. My opposite is 7, my adjacent is I don't know. I'm not going to show the working, oh, I always show the working. Okay, times this side by x to get rid of the x on that side. I'm just left with 7. If I've times that side by x, I have to do the same to this side. Okay, to get that x by itself, if it's been times by tan 48, I need to divide it by tan 48. If I divide this side by tan 48, I have to do the same to the other side. The 7's on there originally, so the tan 48 goes underneath it. Okay, and my answer is 6.3028, blah, 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 so that becomes 6.30, which means that this side here is 6.30. That's kind of close to 7, so I'm pretty sure my answer is correct. And that's it, guys. That's how to solve trigonomic ratios with the denominator as the unknown.